Hi guys, I hope everybody enjoyed a beautiful day today. We are going to continue the mathematical induction. Notice what we did so far is we proved that whatever sequence we had is equivalent to some formula. We followed the same steps. We did the base case for every example. We then did the induction hypothesis, and then we were able to write down the conclusion. I will look into your homeworks shortly. I hope the mathematical induction by now is your favorite thing. You will be thankful you learned this when you will be taking a college level math classes, and you will be working on this, and this is going to be familiar for you. Of course, this is very enjoyable, and you can tell everybody in your household that you know how to prove using mathematical induction. So you can be proud of yourself if you are getting hold of this. So today what we are going to do is we are going to go to the second page of our notes, and we are going to look at example number 3. We are only going to talk about the two examples about the divisibility. And then tomorrow we will move on to the next part. I want to make sure I break this into pieces because again, I do realize that this is a little bit different than anything you have done before in mathematics. So let's take our time and let's make sure we do it right, or as best as we can. So now notice that what we are going to be doing is we are going to be proving that the statement that is given is divisible by some number. And in this case, the statement is 3 to the power of n minus 1 is divisible by 2 for all positive integers. So we have some restriction for our n. Let's keep it in mind. And again, it is kind of like a structure on how to solve those examples. Some of them are easier, some of them get a little bit more tricky. But let's try to do two together, and then we'll go from there. So we are going to start with the base case, and we are going to see if this statement is true. I am testing 1. So if I plug in 1 for n, I will have 3 to the power of 1 minus 1, which is equivalent to 2. And I know that 2 is divisible by 2. Well, just for fun of it, let's keep going. What happens if n is equivalent to 2? I would have 3 to the power of 2 minus 1, which is 9, minus 1, which is 8. That's fine. That's also divisible by 2. Well, let's keep going. N is equal to 3. So 3 to the power of 3 minus 1, that's 27, minus 1 is 26. And I hope you can see the pattern, and I hope you can see that this is always going to be true. But again, if you want to prove something in mathematics, you need to show that every single number would work. So again, mathematical induction comes in place in here, and we are going to write our inductive hypothesis, and we are going to plug in a k for the n, and we are going to say that this is some kth element. So whether you want the k to be equal to 55 or 56 or 198, whatever number you want it to be, if we are able to prove that the next number after whatever number you choose works, that means that this statement is always going to work. So inductive hypothesis, n is equal to k, and then I'm going to assume that 3k minus 1 is divisible by 2. So now the next thing that we need to do is we need to keep in mind that we need to prove that the next term is going to work. So I wrote it right in here, and then I am going to explain what I wrote right on the side. We want to show that the formula for n is equal to k plus 1. So we want to show that it holds for something that looks like this. All right, so notice what I am doing. In place of now n, I am plugging in k plus 1. Now, this is just an expression. It is not given as an equation, so we really cannot be doing anything to both sides. We really cannot be adding or subtracting anything because, again, we can only do this for the equations. So for that reason, now I want everybody to look at this line. I am still at my original statement when I plug in the 3k. I do not have the k plus 1 here. I only have 3k minus 1. So this is after I plugged in k. I am going to say that this is equivalent to 2r. And I am going to make some kind of restriction that r is not any number, it is some integer. And I probably should say that it is positive integer. Just because we were talking about the positive integers before. Now, what I am going to do is I just created an equation. And notice that this equation has two variables. And if I can make this equation to look like this one, where I have the 3k plus 1, where it is going to indicate the next term, then I will be good. So notice, I have to use all the properties of algebra that I do know in order to do this. So my first step, because again, this is where I am going, I want this to be equal to this, is I am moving the 1 on the other side. I don't want the 1 to be there. So now if you want to move this negative 1 on the other side, we are adding it. Whatever you do to one side of the equation, you need to do to the other side. So now I have that 3 to the power of k is equivalent to 2r plus 1. Perfect. Now I do want the 3k plus 1. So remember the properties of exponents. I want you to see what I am doing. I am multiplying both sides of the equation by 3. You will see in a second why. Well, this is giving me 3 times 3 to the power of k, and then 3, and then whatever I am multiplying it by. Now, remember, this is 3 to the power of 1. And because I am multiplying the numbers that have exactly the same basis, I am going to be adding the exponents. So now this is equivalent to 3 to the power of k plus 1. I am putting those two things together. I use the distributive property for fun of it, because I could. And now this is almost starting to look like what I wanted. But in order to look exactly like it, I need to have the 3k to the plus 1 minus 1. So because this is an equation, I am going to take away 1 from both sides. So from this 3, I am going to move 1 on the other side. And once you do it, you will get 3k plus 1 minus 1 is equivalent to 6r plus 2. Now, I need to show that this expression now, that this part is divisible by 2. And if you are able to factor 2 out, that means that whatever you will get as an answer is equivalent to 2 times something. And if you have 2 times something, that is always going to be divisible by 2. So notice, this is my next term. And then I was able to write that next term as 2 times something. And that means that this is representing the integer divisible by 2. All right, so now here's my conclusion. By principle of mathematical induction, 3k minus 1 is divisible by 2 for all positive integers n. A little bit different. Let's take a look at the next example. The next example is going to be fairly similar, and then I will give you a couple to practice as homework. So next one is example number 4. And again, we will do this one together, and then that is going to be it for today. So now I want to prove that 4 to the power of n minus 1 is divisible by 3. All right, we are going to start with the base case because we always do. So now we are going to plug in n is equal to 1, and we will see if that number is going to be divisible by 3. Well, it is in here. Again, for fun of it, just because we can. Let's see what would happen if I take n is equal to 2. Well, that would give me 4 to the power of 2 minus 1. That is 16 minus 1, that is 15. 15 is divisible by 3, that will work. Let's take a look. N is equal to 3. 4 to the power of 3 minus 1. 4 times 4 is 16, times 4 is 64, minus 1 is 63. 63 is divisible by 3 because sum of those numbers is equal to 9, so I know that this is going to be true. All right, next thing, inductive hypothesis. What I'm going to do is I'm going to plug in n for k, and I am going to assume that the formula holds for the n is equal to k. So the only thing that I am changing at this moment is I am saying that 4 to the power of k minus 1 is divisible by 3. Okay? Now, I want you to see how this is written a little bit differently than before, because we are not starting with an equation. So I want to show that the formula holds for the next term, and the next term is going to be 4 to the power of k plus 1 minus 1. Okay, so again, I am writing this a little bit on the side, and I am going to take my 4k minus 1, and in this case, because I want this number to be divisible by 3, I am going to describe it as 3r, where r is some integer. All right, so now this is your starting point, and what you want to make this look like is you want to make this look like this. So 3 to the power of k plus 1 minus 1. First step, let's get 4 to the power of k by itself. So let's eliminate this one by adding it to both sides of the equation. So at this moment we are here, we have the 4 to the power of k is equivalent to 3r plus 1. This is a similar strategy like we used for the previous example. Because I want to have 4 to the power of k plus 1, if you multiply it by the same number, this is 4 to the power of 1, you will be adding the exponents. So now we have 4 to the power of k plus 1 is equivalent to, well, I did use the distributive property because I will have to move 1 as my next step. So that is going to give me 12r plus 4. Again, I need those two things to look identical. So I minused 1 from both sides of the equation. And now finally, now I am going right in here on my paper. This is going to give me 4 to the power of k plus 1 minus 1, just because I have to have it look like this. So I am moving 1 unit from this side to this side. If you take away 1, this is going to give you 12r plus 3. We want our expression to be divisible by 3. So as long as you can factor 3 out of those two terms, you are good. And I can. Both 12 and 3 are divisible by 3. Once you factor 3 out, you have 3 times something. Think about this. If you are able to multiply the number by 3, that means that it is divisible by 3. So here we go. Integer is divisible by 3. And the only thing that I did not write here, which we do need, is we have our conclusion. By principle of mathematical induction, for n minus 1, oops, minus 1 is here, is divisible by 3. For all positive integers n. All right. Well, I hope everybody enjoys this. More to come. You see the notes, so you see that we are going to be proving the inequalities, and we will bring it one step farther the day after. Make sure you do the assignment that I will assign, and make sure you have fun with it. And also, please come see me if you need any help. It's always fun to work with you. And enjoy the day.